All right, let's jump right in. We're going to dig into some fascinating university lecture notes to really pull back the curtain on what artificial intelligence is. Now, that's a term you hear absolutely everywhere, right? But it's not just one thing. Actually, it's better to think of it as three totally distinct but equally powerful capabilities.
So that begs the question, what does it even mean for a machine to be intelligent? Does it mean it can reason through a problem like a detective? Does it mean it can learn from experience like a student? Or maybe it means it can plan and act strategically like a chess grandmaster? Well, the answer is, yep, all of the above. You see, AI isn't just one thing. It's this collection of different, amazing skills.
And to make sense of it all, we're going to break it down using what I like to call the three pillars of AI. We'll look at the logician, then the student, and finally the actor. And then, for the grand finale, we'll see how these three come together to build the kind of jaw-dropping AI we're all talking about today.
Okay, first up, pillar number one, the logician. This is AI in its purest, coldest, most logical form. Think of a system that runs on nothing but deductive reason. You know, like Sherlock Holmes analyzing clues or a supercomputer calculating millions of chess moves per second.
And to get a real feel for this, check this out. It's an actual university exam question. It sets up this whole Pulp Fiction mystery. Here's the deal. Pahul is a gambler. All gamblers either were loyal to the crime boss Vishuput Singh or they hated his guts. And we know Pahul tried to assassinate the boss. So the big question for our AI detective is, can it prove with pure logic that Pahul hated him?
So here's how the AI tackles it. It doesn't read English like we do. Nope. It takes all those messy human sentences and translates them into the pristine language of formal logic. A phrase like, all gamblers hated Viput Singh or were loyal to him becomes a rock-solid mathematical statement. No ambiguity allowed. Then, it just methodically connects the dots, cancels out contradictions, kind of like solving a Sudoku puzzle, until only one undeniable truth is left.
But the logician isn't just about proving facts. It's also about finding the best way to get to a solution. And this is where search algorithms are key. These are basically smart methods for exploring a huge maze of possibilities, whether it's finding the fastest route for your GPS or the single best move in a game of Go.
Now, this little graph is awesome because it's like a window into the AI's thought process. See, an algorithm like A*START doesn't just wander around randomly. At every single point, it asks itself two questions. How much did it cost me to get here? And what's my best guess for how much farther I have to go? That's the H part. Then it explores the path that looks most promising. It's not just brute force, it's strategic.
So the logician is pretty incredible, right? But here's the catch. You have to give it all the rules of the world up front. But what if you didn't have to? What if a machine could figure out the rules for itself just by looking at a ton of examples? And that, my friends, brings us to our second pillar, the student.
This sketch right here, this is the entire game of machine learning in a nutshell. It's a balancing act. If your model's too simple, like that straight green line, it's got what we call high bias. It completely misses the real story in the data. But if your model is too complicated, like that wild red line, it has high variance. It's not learning the pattern, it's just memorizing all the random noise, which makes it totally useless for anything new. The whole trick is to find that just right Goldilocks zone in the middle.
And the main tool we use for this today? You've probably heard of them, neural networks. They're loosely inspired by the wiring of our own brains, built from layers of these interconnected digital neurons. And by carefully adjusting the strength of all those tiny connections, these things can learn to spot unbelievably complex patterns in just about anything.
So how does it actually learn? Well, the process is a surprisingly elegant little loop. Step 1, the network takes a guess. Step 2, it measures how wrong it was. We call that the error. Step 3, it figures out exactly how to tweak its own internal wiring to make that error just a tiny bit smaller. And step 4, it does that again and again, millions or even billions of times.
Okay, now this is where the story of AI takes a really wild turn. For decades, everybody knew the rule you see in that graph on the left. As you make your model more complex, it gets better, up to a point. Then it starts getting worse because it's overfitting. That was gospel. But then, some researchers did something that sounded kind of nuts. They just kept making their models bigger and bigger, way past that point. And they discovered what's on the right, the double descent curve. The error went down, then up, like expected, but then, against all logic, it started going down again.
And folks, this is the secret sauce. This one, counterintuitive discovery is a huge reason we have things like today's large language models. The old wisdom was, be careful, don't make your model too complex. Double descent proved that if you just blow past that breaking point with insane amounts of data and compute, the rules of the game completely change. It was the insight that basically told us, go bigger. And it's what unlocked the AI revolution we're living through right now. So, we have the logician that can reason, and the student that can learn. But a huge part of being smart is about actually doing things in the real world, right? And that brings us to our third and final pillar, the actor. This is an AI that learns by taking action to get what it wants.
The playbook for this is called reinforcement learning, and it all boils down to this simple loop. You've got your agent. That's our AI. It lives inside an environment. It takes an action, which changes the state of that environment. The agent then gets to see that new state, and the loop starts all over again.
So how does it learn what to do? It's basically like training a puppy. Every time it takes an action, it gets a reward. A good move gets a positive reward, a treat. A bad move gets a negative one. And the agent's only goal in life is to rack up as many treats as possible over the long haul. Through millions of rounds of trial and error, it eventually learns a policy, which is just a fancy term for a winning strategy.
So there you have it, the logician, the student, and the actor. But here's the real kicker. The most advanced AI systems out there aren't just one of these things. The magic happens when you start to combine them.
And I absolutely love this slide because it's the lecturer's own handwritten notes. This is the real deal. And look at what he's planning for the end of the course, putting it all together. His own example, learning plus search together, which he notes is what powered AlphaGo. AlphaGo had the deep pattern recognition of the student to feel the board, combined with the strategic, forward-planning search of the logician.
And that's really the ultimate takeaway. The most powerful AI we have today is a hybrid. It doesn't just reason, or just learn, or just act. It weaves all these things together. It's a master logician, a brilliant student, and a strategic actor, all rolled into one. That fusion, that's where the real power is.
So that leaves us with one final fascinating thought. We've seen how combining these pillars created systems that could beat the best humans at their own games. It really makes you wonder, doesn't it? What new, incredible capabilities are going to emerge when these fundamental pillars of intelligence get combined in ways that we can't even begin to imagine today?